Okay, in the box. Okay, and I'm going to write that in the rectangle. It goes from -2 to 2 for x and from -2 to 2 for y. And that's not this one. This is going from -8 to 8 for x and -8 to 8 for y, right? Okay, but in this rectangle, reciprocal shape is a graph of just plain old 1 over x. Okay. All this, the toolkit reciprocal function. Okay. The graph you just constructed. Now, if you didn't get all the construction lines right, you simply got to have that straight. So make sure you got that straight in every detail. Of course, the videos are posted, you can use those with the details. But there are divisions and here's the red dot right in the middle. And I didn't look at every page, but most of the ones I looked at have the red dot there. So that's nice work on all the details. If you got the red dot, just remember it's important. Okay, and remember to put it in there. So what we have is now we labeled the construction lines. Now, a lot of people put numbers down for the construction lines. I want you to put x equals and y equals on the construction lines, because shortly you're going to have to know what the equations of vertical lines are, and if you in the habit of doing that, you're not going to have any trouble with it. Some people often have trouble with. So there's a reason that I want you to put x equals -8 here, x equals 8 here, x equals 0 here, x equals -4 here, x equals 4 here, and it's getting a little tight, so I'm going to label x equals -2 and x equals 2 at the top. And then similarly for y, I'm going to have y equals 0 in the middle, y equals -8 here, y equals -4, and y equals -2. I do have room to label all my y's. I try to put x equals here and x equals here, it's going to get all messed up. So, and I got y equals 2, y equals 4, and put y equals 8 up here. Your construction points are here, here, and here. So there's your curve. Here, here, and here. So there's your curve. All that should be on your paper. And the lines all need to be there. So make sure you know where all the lines go and how to construct them. Okay? Because everybody needs to have all those details down right now, and almost everybody does. Okay. Not hard, just takes practice. Make sure you practice drawing all of these shapes a number of times until you can do them quickly and with all details. And you all as a group have done really well with that. And I need water, don't have any. Okay, so you so just board. And we're gonna do something with this function. So this graph turns out to be of the form y equals a times 1 over x. Okay? Make sense? Okay, so pick one of your construction points. Write the coordinates for that construction. Actually, you probably have a new page for the class. Write down at more or less the top the construction point that you want to use. It'll either be this, or this, right? There's 6 construction points. Write down the coordinates of one of them. And what I want you to do is plug the x and y in for x and y here. Okay? And solve to find out what a has to be. You solve that equation for a. Plug in the x and y of the point you chose and solve for a. Okay, now this is good. Everybody happened, almost everybody that chose a point happened to choose 4, 4. Okay? So nobody, well, I'm going to be contrary. I'm going to choose this point, which is 2, 8. Fair enough? Okay, so we choose 0.28 and we get eight. A equals A times 1/2. Okay. Now, what do you do in order to solve this equation for A? So, how many of you know how to solve that equation for A? Get 2 times 8 equals A times 1/2 by 2. Now I multiplied by 2 on the left here and by 2 on the right here, but that doesn't make any difference because the order of multiplication doesn't affect the result. Okay. So I can get away with that. And I wanted to multiply it here because that's 16. So A equals 16. Did anybody raise your hand if you got A equals 16 when you solve your equation? Okay. You should have, and I think pretty much everybody did. Okay, now the equation most of you chose. Same thing. Here. Now, if we make a table, and I said a comment, well, you made a table. Yeah, you made a table, we handed it in. Okay, table for the function is graph. If you just look at your construction points, you find you have -2, -4, -8, 8, 4, 2. Those are the points on the graph. Now, I haven't checked all the details of what you did, but everybody did so well on the quiz that I think you're good there. Okay. Now, if we calculate y equals 16 times 1 over x, we get 16 multiplied by 1 over -8. Well, 16 over 8 is 2, right? And we got a negative there, so that's -2. That's 16 times 1 over -4 equals -4. 16 times 1 over -2 equals -8. 16 times 1 over 8 is 2. 16 times 1 over 4 is 4. 16 times 1 over 2 is 8. So the numbers we get from the formula match the numbers we got from the construction. Okay. So anytime we construct a reciprocal shape in a rectangle whose red dot happens to be at 0, 0, the origin, we can do this and get the formula for the function. Okay? That makes sense? Now, we're going to go on with transformations because that topic is coming up fairly soon, like maybe even next time, but I'm not sure. If the red dot is at some other point, well, you get a different expression. Okay? And I'm actually going to tell you what that expression is. Well, y'all have done the homework on functions, and that came out quite well. It appeared to have done as they come up. I'm going to say here. Okay, well, I'm going to just ask you to do some function notation. Okay. So let's let series of expressions. What's f of 2? What's f of a plus b? What's f of x plus 3? F of x plus h? F of x plus h plus k? And a times f of x plus h plus k. Let's see if you can answer all those. Okay, now if I can just find the blackboard, I think we can do this. Okay. F of 2. Well, your rule is f of x equals 1 over x. If you do f of 2, that means x equals 2. So you got to write equals 1 over 2. F of a plus b. Well, a plus b is replacing x, isn't it? You use the rule and you replace this x with a plus b and you get this. How about f of x plus 3? Well, you replace this x by x plus 3, and you're going to have to replace this x by x plus 3, so you're going to have 1 over x plus 3. How about x plus h? Well, x has been replaced by x plus h, so again, I'm going to replace that x by x plus h. Everybody understand that? Okay. And then f of x plus h plus k. Okay. Well, f of x plus h, as we just saw, is 1 over x plus h. And k doesn't go into this at all. It just goes on the end, right? This takes care of the function notation, then you add k. All right. And then a times f of x plus h plus k. That's a multiplied by x, f of x plus h, which is 1 over x plus h plus k. All right. Make sense? Any function, any reciprocal shape you draw in a rectangle is going to have this formula. Okay. We just saw that if we draw it in this particular rectangle where the red dot is at the origin, or the red dot is at 0, 0, it's just going to be a times 1 over x. That's what you would get if h was 0 and k was 0, right? Because if h is 0, then 1 over x plus h is just 1 over x plus h is just x, right? H is 0. So you're just going to get 1 over x here. And if k is 0, you don't even bother writing that. You just have a times 1 over x. So that works here. Well, the point of that is hk is the red dot. In other words, h is the x coordinate. If I sketch this thing, there's a red dot. I've got all my coordinates and everything. I'm not going to include them right now. I'm not going to do all the construction. I'm just going to say if the red dot is here, and this is the line, x equals, I don't know, what do you want x to equal? Show me with your fingers, 1 or 2 hands. Okay, first thing I saw was 9. Okay, x is 9. Okay. Now show me with your fingers what you want the y coordinate to be. 5. First motion I saw was a hand raised with 5. Maybe somebody just saying hello, but we'll take it as 5. Okay. Make sense? Okay, now we know. This reciprocal graph has the equation y equals a times 1 over x minus 9 plus 5. Because HK is the coordinate representation of this point, right? And the coordinate is 9, 5. Oh, this is not x equals 5, it's y equals 5. But anyhow, we know that. Okay? Make sense? So all of a sudden, you know everything you need to know to get the formula for reciprocal shape constructed in a rectangle. If you know where that rectangle is and what its dimensions are. Okay? So now, okay, again, show me with your fingers an even number. How wide is the rectangle? How wide do you want the rectangle to be? Okay, I've got a 10 there. Okay. You were starting to do something, but it's still moving. Okay. So if this is 10, then what's the x coordinate here? Say that here to here is 10 units. It's hard to read that. This width is 10. If this width is 10, what's it actually equal to here? Write it down on your paper. Let me see how we're doing with that because we want to make sure everybody can see that. Okay, now we have all the information here we need because this line's in the middle of the rectangle. Always, right? And the rectangle's 10 units wide. So how far is this? 5. Now, if we go 5 units from x equals 9, what are we going to end up with? Got to be 14, right? Okay. Half the width added to the middle gives you the end. That makes sense. So you're still looking a little dubious. So, you know, I want to make sure we understand these numbers because, again, y'all are doing quite well with this stuff, with the labeling and stuff, much better than in previous classes I've had. But there's still a little fuzziness. First about what x equals. Now remember, I keep saying I want you to label y equals, y equals, y equals, y equals. So when I say x equals what, you give me x and not y. Okay. Also, you'll see why it's important. So x equals, I'll write words, if the middle is at x equals 9, and width is 10, then I don't have room to write out all my words, but I'll do it anyway. Half the width being 5, that's why I wanted you to give me an even number so we could do half and not have to worry about fractions, right? if half the width being 5, the right edge is that x equals 9 plus 5, right? If this is 10, that's got to be 5. And if you go from 9 and move over 5, you got to get 14. Okay, so make sure you see that. And if you don't see it, go back and look at this part of the video again, whether you can stand it or not. Okay, you need it. Now, if we know this, if y equals a times 1 over x minus 9 plus 5, what's the value of a? I haven't figured it out yet. Okay, if you got it, I see what you said. I'm not sure I did this when I was on the camera, but I figured out that, okay, it was 13 up here. 13 doesn't equal 14. Got that line there. Well, it's 13 here. Then we can conclude that this construction point here, I think you got that. Okay. Now, just as we plug in the coordinates of whichever construction point you chose here and solve for a, we'll do the same thing here. We just got a couple more numbers in the equation. It's really not much harder to solve for a, but let's make sure we can do that. Plug in 14 and 7 for x and y. Okay, now I really messed up here. I wrote a plus with the h here because I had a plus with the h here. A lot of times it is x plus h, but in this case it's x minus h, and it should have been x minus 9 here, okay? I wrote this correctly, but a lot of you put a plus on that 9, understandably, because that's what I have here, okay? So if you had a plus, that's fine. As long as you know how to solve for a, we can fix it, okay? So see what you get. Okay, so if you have 14.7 on the graph, and this is the function, remember it is x minus h, not x plus h when you do this, okay? 14.7 is on the graph, you want to find a. So you have y equals a times 1 over x minus h plus k. H equals 9, a equals 5, y equals 7, when x equals 14. Okay, so we're going to get the equation is going to be 7 equals a times 1 over 14 minus 9 plus 5. Okay, and that's the equation most of you have. A couple people got a plus there because of my mistake, but that's what we're going to do. What's the first thing you're going to do? Well, first thing you're probably going to do is do that 14 minus 9 because it's in parentheses, right? You're going to get 7 equals a times 1/5 plus 5. Now, what's the next thing you're going to do? A lot of people seem to multiply by 5 because you have a 5 down here, and that's exactly what we did. Well, that's exactly what we did when we solved this equation, which is out there, but I'm not going to pull it over real quick. So you kind of used to multiply by that denominator, so that's a really good instinct. You can do that. Okay, I would subtract this 5 first because you always want to do additions and subtractions before you do multiplications. Well, first you do what's in parentheses, then additions and subtractions, then multiplications. even when you're simplifying an equation. Now, there are exceptions to that rule, but that's the rule you probably want to think about. Okay, so, but I'm going to multiply both sides by 5. We can do it. Well, no, I'm going to do it right. I'm going to do 7 minus 5. I'm not going to do it right the other way too. Subtract 5 for both sides. I end up with 2 equals A times 1/5. Actually, a lot of people have that right and I said it was wrong. Okay, now we multiply 2. So I multiply 5 by both sides. We get -10 equals A, but that can't be. 7 minus 5 is not -2, it's 2. It can do addition and subtraction. Most days when I can find the board, I can do arithmetic. This isn't one of those days. Okay, sorry. A is 10. So a lot of you got that. All right. Now, if we come down to this equation, we multiply both sides by 5. And we multiply the whole side by 5. I get 35 over here. And I get 5 times this and 5 times this. That gives me 35 equals A plus 25, right? 5 times A times 1/5 is just A. Okay, so that we again get A equals 10. It's a lot more involved if I try to multiply by that 5, and some people do. Okay, make sense? Okay, so that's the algebra of the situation. I'm going to give you some problems maybe this weekend on algebra. I might even give you, a couple for Thursday just to make sure you can do this out. What's our conclusion? Function that we drew here in this rectangle at that location is y equals A times 1 over x minus 5, x minus 9 plus k plus 5. So y equals f of x now equals A, which is 10 over x minus 9 plus 5, right? And if you plug the numbers in, you would find that, well, you would find that if you have this thing all constructed and the construction points all labeled, it should agree. It certainly agrees for the point 14.7. If x is 14, x minus 9 is 5. 5 into 10 gives you 2. Add that to 5, you get 7. Okay? Okay, well, let's do something else. Let's have a little more fun with this function. Okay. Time, play around with it a little bit. Now, we talked about composite functions a little bit last time, like an f of g of x thing. Okay? Remember doing that? Okay. Well, you're going to have an assignment on that. Actually, hold on. Yeah, I'm confusing two classes. Let me just double check. No, that's coming up, doing domain and range. Okay. Sorry. Let's go back to the original function we looked at. As this thing is graphed, its domain is the set of all x values that occur on the graph, right? So let me get more room. Start falling off. Okay. Got this function. And when we plugged in all the numbers, we got y equals 16 over x. Okay. As graphed, the domain set of all x values. Well, the x values on this graph go from -8 up to -2. And there are no more x values that correspond to the points on the curve. Okay, so it's a set of all x values corresponding to the points on the graph. And where are those x values? Well, we can draw some points on the graph. And we can figure out what the x values are. They're these, right? You understand what I just did? Now, if I drew all the points on the graph and projected them down here, they go from here to here, right? Including this point and including this point. Does that make sense? There's a point above or below every one of the x values here. There's a point on the x equals line for every x that goes from here to here. Okay. Also, for every x that goes from here to here. So I could say, okay, well, also from here to here. Because all these points come down at the graph, including the endpoints. So we can say the domain is the set -8, -2, and then the set from 2 to 8. Which is x equals 2 to x equals 8. There's your domain. Okay. The range is a set of all the y values. The domain of y equals 16 over x in general the set of numbers from -infinity to 0 union the numbers from 0 to infinity. Why do I say that? Well, division by 0 is forbidden, right? You can't divide by 0. We talked about that last time, didn't we? You talk fairly extensively about why you can't divide by zero, but accept that you can. And you can't do the square root of a negative number. Okay. Those are the two things you gotta watch. Okay, let's think about the domain of the function we just got. Now, we make a distinction. This is the domain in general, not the domain of the graph we just made within the rectangle. The rectangle restricts the domain, okay? And it also restricts the range. Okay, we got the function. What number cannot be in the domain? Anybody give me a number that we can't plug in here? 9, we can't plug in 9. Why can't we plug in 9? Because if we plug in 9, we have a 0 in the denominator. So when you're looking at some of the problems, some of the expressions, you look for denominators. Okay? Denominator can't be 0, so x minus 9 equals 0. X minus 9 is the denominator. So x equals 9 isn't in the domain, so the domain is everything from negative infinity to 9 and everything from 9 to infinity. The only number that isn't in the domain is 9. Is that clear? If I had the g of x equals, let's just say 1 over the square root of 4x. I don't even want to do reciprocal. I'm going to say the square root of 4x plus 12. Then four x plus 12 can't be negative. It can't be negative, then it has to be greater than or equal to 0. We can solve that easily. We say 4x plus 12 minus 12 has to be greater than or equal to 0 minus 12. Subtract 12 from both sides. So that 4x is greater than or equal to negative 12. 4x over 4, and that is greater than or equal to negative 12 over 4. So x has to be greater than or equal to negative 3. It's very easy to get this as soon as you see that whatever is under the radical has to be greater than or equal to 0, right? You just write out whatever's under the radical is greater than or equal to 0 and treat this just like an equation, except as you should know, but maybe a rusty, if you happen to divide by a negative, you've got to reverse the inequality. Okay? And that's one thing that might throw you off a little bit on the homework. We're going to see examples. Okay? So the assignment for next time is going to be on domain and range. We'll be doing before class next time. Okay? Get it done.
I got that access to the jump.